Okay, can we start?
Yes.
All right. Now, so the first question over here, okay, is actually written about, okay, 2-bromopropane reacts with a hot concentrated sodium hydroxide in ethanol. Now, when you have sodium hydroxide in ethanol, what kind of reaction that will take place over here? Ethanolic sodium hydroxide. Frame?
Substitution.
No. Ethanol. Okay, when you have ethanol, okay, we have elimination reaction. So there are 3 substitution reactions, okay? So the first one is going to be sodium hydroxide, then ammonia, then I think KCN. This one must be in ethanol, and then this one must be in aqueous, okay? So after that, we actually learned about elimination, where sodium hydroxide, when it is going to be in ethanol condition, you are going to get an elimination reaction. It means you are going to actually remove the Br. So it means, like, for example, propane. So if you have Br over there, so what happens here is going to be this HBr is going to be removed, and you are going to get something like this, which is going to be an alkene. Okay, so here they're asking you, what do you get? Okay, what do you get is going to be propene. Okay, take note of this. Okay, by 2 o'clock today, you are going to have a test later for this chapter. I think you need to be very certain on the concept. Yeah. So there are 3 reactions plus 1 reaction involving elimination. Okay, take note of this. If you are still not sure about this, you can always double check with the video that I made earlier on, and I shared that with you with through the WhatsApp group. Okay, now second question, hydrolysis of 1-chloropropane, okay, to produce propan-1-ol, okay, is much more slower than corresponding hydrolysis of iodopropane. So basically, you are going to have propane, but the propane over here is going to be 1-chloro, so you have Cl over there, and then if you compare with iodine over there, they say that this one is slower, okay, this one is slower, the hydrolysis, and this one is faster, okay. So the reason why it's faster, okay, should be the bond between the carbon and the iodine should be easier to be broken. And this one, you should know that, okay, as they go down group 7 or 17, okay, the Cl, okay, Br and I, okay, the ionic, the radius, okay, generally the molecules, the atoms gets bigger and bigger. So it makes the bond length, okay, the bond length is going to be longer. Now, if you have a longer bond length, you are going to have less bond energy. So it's easier to break them, okay, easier to break them. So this one you need to actually help to actually explain to them. Now, here, chlorine is much more electronegative than iodine, okay. If they are more electronegative than iodine, no issue. You have delta negative, delta positive, right? If it is more electronegative, should be faster, but they say this one is slower. Okay, so nothing to do with the electronegativity. Okay, this one got to do with bond length and bond energy. So you see the bond strength of Ci bond is less than the CCl bond. This is the correct one. Okay, the bond energy is less, so it's going to be faster. Carbon atom in CCl bond is going to be more positive than Ci bond. So similar with the A, okay, doesn't mean anything. Okay, the hydrolysis involves nucleophilic addition reaction. This is totally a wrong concept. Okay, this one is going to be, if you want to do hydrolysis, okay, basically this one is going to be nucleophilic substitution. So it's not addition. Okay, so the answer here is going to be boy. Are you following me so far?
Yes.
Okay, let's go for question number 3. Halogenoalkanes undergo a range of nucleophilic substitution reaction. Which one is only by SN1? Now take note, SN1 is going to be formation of carbocation. And then SN2 is going to be the formation of intermediate. Okay, this one you need to actually understand by now already. Now here they say just by SN1. So carbocation means it's going to actually tertiary halogenoalkane tend to actually undergo the formation of SN1, which is tertiary carbocation is much more stable compared to the others. So now what we need to do is we just need to actually find out which one is going to be the tertiary halogenoalkane over here. So if you look over here, this one is primary halogenoalkane, so no, okay. So if you look over here, this is going to be primary. If you are concerned about how come Mr. Gopi can get this one as primary, so you can draw, okay, CH3 and then CH2 and then you have Br. So this one is going to be the carbon attached to the Br, okay, is only attached to one R group, so it's primary halogenoalkane. We are looking for tertiary halogenoalkane. So you do the same, okay, you will notice that this is going to be a tertiary halogenoalkane. And even here, if you try to draw, it's going to be CH, and then you have Br, and then CH3, and then CH3. This is going to be secondary. So this one is going to be tertiary. So this is going to be the answer. Okay, so you need to actually know about this. Number 4, okay, it's a very easy question for now because we didn't learn so many mechanisms yet. Okay, but now in the hydrolysis of bromoethane, it's a halogenoalkane by aqueous sodium hydroxide. So sodium hydroxide will give you this ion over there, which is going to be the nucleophile. Okay, nucleophile. So that's why they call it nucleophilic substitution. So what is the nature of the attacking group? The attacking group must be a nucleophile. Okay, must be a nucleophile. But once you attack, you are going to actually get a carbocation, for example, if it is bromoethane. So if you have bromoethane, let's say this is going to be Br. So when I have OH minus, okay, what's going to happen? Okay, if I put in form of mechanism delta negative, delta positive, this one will give you CH3, CH2 plus, okay, and then the OH minus, okay, will come and attack, okay, will come and attack over here. So they are going to actually give you the CHOH over there. Okay, so here, this is going to be what they are telling is the attacking group. Okay, the attacking group is going to be the nucleophile. And how about the leaving group? Okay, the leaving group. Okay, the leaving group is going to be the Br. Okay, the Br, when they leave, they are going to take away the electrons. So you are going to get Br minus dot dot. Now, what can you say about this leaving group? Is this a nucleophile or is it going to be electrophile? Frey? Definition of nucleophile. Definition of okay. This one is going to be negative. They are going to attract to positive. So it's a nucleophile also. Okay, it's a nucleophile also.
Yes.
So the answer over here, okay, is going to be the definition of nucleophile is any species that has lone pair of electron. Okay, they are more electronegative. They will attract the electron. So they do have electron pair. So this is going to be nucleophile also. Okay, so that's going to be the answer. Nucleophile and nucleophile. Okay, additional questions. Very important question over here. Okay, take note. Now, next question, question number 5. Now, 1,1-dichloropropane, okay, they react, okay, with aqueous sodium hydroxide in series of steps. So it's not going to be a single step to give you propanol. This is aldehyde. Now, in order to get, okay, halogenoalkane to change into aldehyde, what you need to do is, okay, here they say that it's going to react with sodium hydroxide aqueous. So what's going to happen is going to be the Cl, okay, is going to be replaced by alcohol. It means going to be replaced by OH. It's a substitution reaction is going to happen. And once you get the alcohol, okay, next what's going to happen is going to be the alcohol. You just need to oxidize the alcohol to become the aldehyde. So what's going to happen generally here is I'm going to actually do some kind of a substitution first, okay, because that's the first step, okay, because chlorine, okay, halogenoalkane, when you react with sodium hydroxide, the first reaction is definitely not addition, okay, it's definitely not addition, okay, if you are, this is propane, yeah, so propane is going to be alkane, Okay, so it's going to be halogenoalkane. Halogenoalkane. So halogenoalkane do not undergo addition reaction. We do not have elimination reaction because the sodium hydroxide is not in ethanol. So in order to have elimination, it must be in ethanol. So it's not going to be, first reaction is not going to be oxidation. You don't have halogenoalkane undergoing oxidation. So the first reaction must be substitution. So that's going to be the answer. Next question. Now here you have a compound, okay? You have a compound, a carboxylic acid, okay? And then they say that when you heat them under reflux, okay, with sodium cyanide in ethanol, okay, followed by acid hydrolysis, okay, what is going to be the compound, okay, which compound will produce this molecule, which compound will produce this molecule. But take note, it's going to be KCN, okay? When you react something with KCN, what will happen, Jody? When you react something with KCN, if this is going to be the reactant, what will happen to the product when you react with KCN?
The carbon plus one.
Yeah, it means the carbon will add, right? It means the number of carbon will increase.
Yeah.
Okay, the number of carbon will increase. So it means that if you have, okay, for example, if I count the number of carbon here, 1, 2, 3, 4, 5, 6, and 7, because C2, yeah. Okay, if you have 7 carbon as the product, the reactant must have how many carbons, Victoria?
8.
No. It means KCN is a reactant, a region that will actually add the number of carbon. So if you have, this is the product. If the product has 7 carbon, my reactant must have must have 6 carbon only. Can you understand, Victoria?
Yes.
Okay, so you must actually look for, okay, you must look for something that has 6 carbon first, okay? Anything that has different number of carbon will not be the answer. So if you see 1, 2, 3, 4, 5, 6 might be the answer. 1, 2, 3, 4, 5, 6 might be the answer. 1, 2, 3, 4, 5, 6, 7 cannot be the answer. 1, 2, 3, 4, 5, 6, 7 cannot be the answer. Okay, you already eliminated C and D. So now what we need to do is we just need to focus on the A and B. Okay, we just need to focus on A and B and find out what will be the answer. Okay, so here, okay, you are going to actually react KCN with KCN. So it must be substitution of this BR. Okay, must have substitution of the BR. So if I substitute the BR over here, what I will get CH3, CH, CH3, CH2, CH, CN, okay, and then CH3. The same thing here, CH3, CHCN, CH2, CH3. Now, the next step, okay, is going to be followed by acid hydrolysis. It means there is going to be this CN is going to change into carboxylic acid. Okay, so it means if I just change a bit, okay, it's going to be double bond O and then OH. So here, double bond O, this one will be OH. So if I try to actually compare which one will give me this molecule, okay, just take a look. CH3, 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 so possible here. And then after CH, you are going to have CH and CH2. This one, you are only having CH2. Okay, if I draw focus on B here, you have CH3, 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 CH, 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 then C2H5. This is C2H5. It can come directly to this carbon and then followed by carboxylic acid, So that is going to be the answer. Can you guys understand? B. Number 6.
Yes.
Okay, you just, for this one is wrong, okay, because it has CH2. There's no CH2 here. Okay, so this is going to be the molecule that we are looking for. Okay, so this is going to be, the answer is going to be B. I'll go for other question, number 7. Now, chloroethane can be used to make sodium propanoate. Now, you see chloroethane, sodium propanoate. Okay, so here the intermediate Q is hydrolyzed with boiling aqueous sodium hydroxide. Okay, and then to give you sodium propanoate. It means they actually hydrolyze this, okay, with sodium hydroxide, okay, and then it gives you a sodium propanoate. Now, in this case, which region will produce the intermediate Q from chloroethane? Now, take note, whatever it is, sodium propanoate or whatever, propan is 3 carbon. Ethane is going to be 2 carbon. If you want to change 2 carbon to 3 carbon just now, okay, I'll call Victoria again. Victoria, 2 carbon to 3 carbon, what you need to add? What is the region do you add when you are trying to increase the number of carbon?
KCN.
Okay, it's close, okay, but it's not HCN. Okay, it's supposed to be KCN. Did you mention KCN or HCN?
Okay, KCN.
Yeah, KCN. Okay, KCN. So the answer is going to be D. Okay, potassium cyanide will be used. Okay, so you are trying to actually change, okay, from 2 carbon to 3 carbon. Whatever happens next, okay, you no need to worry. Okay, no need to worry so much about it. I just want you to focus on, okay, there's 2 carbon here, ethane, and then I'm going to actually change it into 3 carbon. So the first thing, I need to actually react with KCN. So I don't react with HCN. It's not in your syllabus. Okay, KCN. Okay, HCN is later. Okay, number 8. Now, aqueous sodium hydroxide reacts with 1 bromopropane, okay, to give you propan 1-ol. So here, okay, you have aqueous sodium hydroxide with halogenoalkane to give you propan 1-ol. So this one is normal substitution reaction, yeah, nucleophilic substitution reaction. But they are asking what should be the first step in the mechanism. Now, when you have bromopropane, okay, this is bromopropane, okay, this Br, and then when you have OH minus, the first thing that should happen is the electron supposed to go over here. Delta positive, delta negative. Then after that, the negative will go over here. So here, by which one should be the answer here? By a curly arrow from a lone pair of OH ion to the C plus on the bromopropane. So this one is possible. Curly arrow from C delta positive to OH. Wrong. Okay, it's supposed to be from OH to over there. It's a movement of electrons. So this one is wrong. Curly arrow from CBr bond to the carbon atom. Now, you see, it's supposed to be CBr bond to Br because Br is more electronegative. So this one is also wrong. The homolytic fission. Now, do remember, homolytic fission only happens for alkane. Okay, and then that one is also homolytic fission happens for Cl2, for example, under the presence of sunlight. Okay, this one is going to be heterolytic fission. Okay, if you want to actually mention, it's going to be heterolytic fission. So this one, the answer is going to be A. Okay, that's going to be the answer for number 8. Number 9. Okay, now number 9. Okay, this is a very new term, a carboanion. Okay, in an organic compound has negative charge. Carbocation, we know, okay, is a positive charge. The reaction with 1 bromobutane and sodium hydroxide, similar like just now, proceeds with SN2 mechanism. Now, SN2 mechanism is the formation of the intermediate. Do remember, SN1 is carbocation, SN2 is intermediate. Now, which one is the first step of this mechanism? Now, the first step of this mechanism is going to be, okay, attacked by nucleophile on a carbon with a partial positive charge. I think that will happen. Now, how about the next? Heterolytic fission followed by an attack. Now, take note, heterolytic fission do not happen first because intermediate is going to be formed. So you need to attack first, then only the BR can go out. So here, this is wrong. Heterolytic bond fission followed by attack of the nucleophile on carbocation, anion, all this. No. Okay, do remember intermediate will be formed at the same time. It means you need to attack. The nucleophile should attack the carbon. After that, okay, the presence of extra electron will repel the BR also to go and then undergo the heterolytic fission. Okay, so this one, homolytic fission, no, definitely not homolytic fission. So this is going to be A. Okay, number 10. Okay, this is going to be a follow-up to all the questions that we have done earlier. Now, here they say it's SN2. Just now also we mentioned SN2. Intermediate is going to be formed. Now, when you have intermediate, okay, so take note, there's no carbocation, something like carbocation over here shouldn't be there. Okay, so here they say that when you react with sodium hydroxide, the substitution follows an SN2 mechanism, which structure represents a species formed during the reaction. Now, the species that is formed during the reaction means they are asking which one is the intermediate. Okay, which one is the intermediate? So you need to mention about, okay, the bond, okay, the Cl bond is going to be broken and then the OH bond is going to be formed. So something like this, okay, this is the intermediate. So definitely you are not going to get this, okay. So I need to choose between C and D, okay. Janice, which one will you choose between C and D? Which one do you think is going to be the best answer for intermediate?
C.
C. Why?
Because in D, the delta negative is on the C. It's supposed to be delta positive. So D is incorrect.
But the answer, I'll tell you, the answer is D. Okay. Now, I'll tell you why. Okay, because when we do the intermediate, okay, this one is correct. Okay, it's the Cl. Okay. Now, do remember the intermediate is preparing itself, okay, to break the bond between the Cl. Cl have to go off, and then the OH supposed to form the bond. Okay. Now, what happens over here is, do remember the OH carries a negative or the electrons. The electrons is given to the carbon. Now, when the electron is given to the carbon, it will actually make the carbon to be partially negative. Okay, because electron went to the carbon. So no longer it's going to be delta negative over there. It will go, the electron will be closer towards the carbon. So the carbon will have a negative charge now. Okay, and then chlorine is going to be a negative charge. Now, what happens between negative and negative? They will repel. Now, when they repel, so what happens? The bond will be broken. So it is actually what this diagram is very good, okay, in actually showing us that this is going to be the repel, the negative charges, they will repel. So they are going to actually make this bond to be broken. So that is going to be the best answer compared to this. And why it is negative charge? Okay, take note, because extra electron is given in by the OH. So the entire molecule is negative until, okay, the Cl goes out. Okay, when the Cl goes out, you are going to get Cl minus, and then this one is going to be like normal, neutral. Okay, so this is going to be the reason why the answer is going to be D. Is that okay, guys?
Yes.
Yeah, it's already 10:01. Okay, I didn't get the time to actually go through this. So this one is going to be your homework. Now, don't worry, it's actually not something very difficult. Okay, it's directly related to the theory. So I want you, okay, to complete these 10 questions together with these questions and submit through Google Classroom. Is that clear? It's already 10:02, guys. I have to go. Thank you, guys. See you at 2 o'clock.
Sure.
Yeah, 2
Bye,
o'clock.
sir.
You must have 2 devices. Yeah, see you.
Sir.
Bye. Yep.
Bye, sir.
See you.